This video follows the theme of a New Scientist article by Michael Brooks, issue 2872, which you are encouraged to read at the address shown. We then offer a different view. This video was made because you were being kept in the dark, and the world needs to know more about an important discovery. Researchers have recently stumbled onto something on the nanoscale that is already being used to clean circuit boards and restore polluted lakes. Scientists have no clue what they are sitting on or its fantastic potential. In a 2003 publication, I predicted exactly this undiscovered type of matter. Just because I said that these contact aggregations were without charge, mass, or inertia, and did not interact with any force, including gravity, nobody believed it. These aggregations have absolutely no connection to the outside. All bonds are mutual and internal. The book even details how the aggregations formed, and much more. But take heart. Now there is in-your-face, hard evidence that it does exist everywhere. Originally, I dubbed it satisfied matter, but now think cloistered aggregate matter would be more descriptive. One could even get fancier and call it clostrolium aggregatum. Tiny cloistered aggregations tend to float aimlessly in an inertial reference frame and pass right through you, or stow away inside lattice molecules, which are mostly space. Even though this stuff is everywhere, it is so inert and elusive, I never dreamed that it would be discovered here on Earth. Larger aggregations, being weightless, would be displaced by the atmosphere, so I hoped for a space mission to collect some. No takers. It is precisely because contemporary science has no explanation for what you are about to see that my explanation of necessity goes outside the box. It is the only one that fits all of the experimental results and makes sense. I challenge anyone to do better. Before we get ahead of ourselves, let's have a look at how a unique set of materials and experimental conditions coaxed the little critters out of hiding. You have all seen water bead and roll off a newly waxed car, or on a Teflon frying pan like this. Not everybody has a state-of-the-art lab like this. A hydrophobic surface such as this, and water, are two of the key elements in the discovery. Hydrophobic literally means afraid of water, but in practice simply means that they do not like each other very much. The hydrophobic material has even distribution of charge, unlike the polar water molecules. For this reason, it is difficult to form hydrogen bonds between the two materials. Water molecules are not attracted to the surface as much as they are to other water molecules, and so they bead up. This is strictly an explanatory animation, again cooked up in my lab. It was, of course, much more precise equipment which produced the first hint of something missing in the science books. The New Scientist article says it was in 1994 when John Parker at the Institute for Surface Chemistry in Stockholm, Sweden, was measuring the repulsion between two water-resistant surfaces immersed in water. As Parker forced them together, the repulsive force between them first increased as expected, then, at a distance of a few hundred nanometers, it suddenly and inexplicably dropped off. A few years later, a semi-plausible explanation was put forward. It unfortunately earned a derogatory and distracting label that stuck. The suggestion was that if the surfaces were populated by nanoscale bubbles, they would merge to minimize their surface tension as the plates neared each other. This would reduce the repulsion. Close, but no cigar. Mainstream science immediately pounced on this explanation and labeled these theoretical bubbles Impossibubbles. Because any gas bubble of that size would need an internal pressure of 100 atmospheres to survive. Of that size? Nanometers? Wait a cotton pickin' minute. Just how close is that? Not to scale, but this is one way of looking at it. Everybody can relate to half a door height as a real meter. So let's start with that. Now, take 1/1,000,000th of that.
And we are down to bacteria size, which requires a millionth scope to see. So that's why they call it a microscope. Finally, take 1,000th of that, and we are down to a nanometer.
Now that we are on the nanoscale, we can better represent the next experiment reported in the article. Our plate with a hydrophobic surface is in water saturated with gas molecules. The incredibly fine tip of a scanning probe microscope felt what was interpreted to be hemispheres on the surface of the plate. I believe the previous experiment prompted the unfortunate assumption that the Impossibubbles had been found, and judging by their size, must be formed by about 1,000 gas molecules. Spectroscopic examination only reinforced the misconception because it did detect a concentration of gas molecules. I suggest, however, they did not realize that the hemisphere previously found was merely a thin formation of gas molecules, much like birds in flight, rather than a bubble full of them. As we shall see on the next slide, the spectroscope was also likely fooled by a concentration at the apex. Now it gets really interesting. They dragged out an atomic force microscope, which detected a flow of gas molecules leaving the apex of the hemisphere. A flow is quite an understatement. 1 billion gas molecules per second were shooting out. It was like a subatomic gas jet. Problems. If the Impossibubble only held 1,000 gas molecules, how could it sustain an outpouring of 1,000,000 times that? Was the driving force the internal pressure, which was already declared impossible? Even so, how could that pressure be sustained considering the apparent outflow? Did dispersed gas molecules somehow slide along the plate to replenish the Impossibles at the interface? How could gas molecules re-enter the Impossibubble against such an assumed pressure? We now part with the magazine article. You are about to see what really happened. Just to reinforce, there were no gas bubbles, impossible or not, but there were formations of gas molecules. Now, what actually creates these formations is even more amazing than an Impossibubble. A tiny cloistered aggregation of matter particles is not only weightless, etc., as previously mentioned, it is also the most solid form of matter in the universe, because the constituent particles are in physical contact. Gravitons cannot get through. In other words, it is a gravity shield. The tiny shields are everywhere, but tend to accumulate comfortably in the no man's land between the hydrophobic surface and the water. At this point, may I remind you that after the Big Bang, it was an energetic free-for-all, involving all kinds of matter particles. Nature tried every possible permutation and combination, some of which are yet to be discovered. Just because you can't see or measure something does not mean it's not there. You can't prove a negative. And as I once heard Benny Hill say, just because there are no complaints does not mean that all parachutes are perfect. Now we see the driving force behind the gas jets. It is the gravity of billions of distant stars. The tiny shield prevents the gas molecules from being pulled back by the gravity of anything else. This is how the gas jet gets beyond the now shown thin shielded zone surrounding the aggregation. The tiny shield itself is ineffective against the massive and relatively immovable plate. The shield is instead held against the plate by water pressure. The peculiar formation of gas molecules around the shield is roughly hemispheric because of a balance struck between the shield's spherical shielded zone and the tendency of dispersed gas molecules to replace those being pulled away at a great rate of knots. One might ask, why do the gas molecules shoot off in one particular direction? Well, they do evacuate the narrow shielded zone in all directions, but there is no sustained flow. As we shall see next, the plate establishes an axis of symmetry for the convection flow of gas molecules, and the direction shown becomes the one with the most equilibrium. Finally, the whole picture. Remember, everything shown is still on the nanometer scale. The gas jet extends only a short distance before dispersing. Gas molecules just dispersed and others in the water join the parades of successive replacement back to the apex. Now that we see the overall pattern, it explains the first experiment. When two plates having numerous such patterns are brought together, the jets contribute to mutual repulsion of the plates. As the plates are forced even closer, however, the outflows of one and inflows of the other begin to interfere. The symmetrical convections break down, and this is the reason for the unexpected sudden drop in mutual repulsion. If you are still with us, we will not bore you further. If interested in where this leads, you can pause your player on any of the brief text screens that follow and read at your own pace.